People have always used color as a means of expression. Prehistoric man created paint from a mix of dirt and animal fat or spit. Over the centuries, pigment production has become a lot more sophisticated. Chemical manufacturing produces synthetic mineral pigments to add color to the products in our world. From pavers to paint to plastic and cosmetics, this is where the color comes from, synthetic mineral pigments. They start with a salt recycled from the steel industry. In this case, it's iron sulfate, which has a bluish-green hue. They add warm water and they're ready for the next ingredient. High-quality scrap. It's another source of iron and it's about to be recycled into pigment. Crane claws transfer it to the mix. Chemicals are added. Every so often, a technician scrutinizes a sample of the yellow slurry. If he decides the color or thickness aren't quite right, adjustments will be made. The slurry now flows over a perforated metal drum with a filter cloth stretched across it as a spray of water rinses off the salt. The fluid in the yellow slurry is sucked through the filter cloth and into the drum, leaving a more concentrated pigment on the surface, called filter cake. The filter cake falls in chunks onto a screw conveyor and ends up at the top of a towering spray dryer. Inside, machinery presses the highly concentrated pigment through the holes of a rotating disc. This causes a spray of droplets that, when exposed to hot air, dries into pigment particles. This yellow pigment is now ready to be mixed into an emulsion paint for coloring wallpaper. A generous amount can produce a bolder shade. A little less, and it's a more mellow yellow. To make black pigment, they start with cast iron filings, another form of automotive scrap. This magnetic crane transfers the filings for production. And again, it will take a chemical reaction to produce the pigment slurry. The chemical reaction also generates energy that's recovered and used in the manufacturing process. They wash and thicken the black slurry on a revolving drum, just like they did for the yellow pigment. But this thick paste won't just be used to make black pigment, it will also be used to make red. For the dramatic conversion to red, the paste flows directly into a kiln, where it's baked until dry. They introduce air and increase the temperature to 850 degrees Celsius, making the black particle turn red. They transfer the red pigment to a drum, where they mix the pigment and adjust the color properties. Then they grind it to a finer consistency. Once the pigment is packaged in paper bags, it's ready for transport or warehousing. Like sugar, pigment comes in both a powdered and granulated form. This demonstration shows the difference between the two. The powdered pigment is more clumpy and doesn't flow from the opened end of the beaker. By contrast, the granular pigments are tiny microbeads that flow freely, which makes it desirable for users who want to mix and meter pigments more easily. To test how the pigment would color brick, they mix red pigment with a concrete substitute and compare the result to the standard to confirm that they match up. But sometimes, they need a real concrete example of a pigment's color tone, so they add a small amount to a mixer full of aggregate, water, and cement. The mixer rotates, and once the ingredients are thoroughly blended, they open the lid to reveal the red brick paste. They scoop it up for transfer to a brick-forming machine, and then fill brick forms with the paste. They activate a plunger that tamps it down to compact it into the forms, producing bricks. Red, black, or yellow, these pigments are sure to make things more colorful.